I'll let you start. I think everyone knows what we're covering tonight, the G1000 program.
Yeah, there's this slide. Just make sure you're in the right virtual room. Okay, so thanks everybody for attending. I will try to keep this in an hour and a half, but there's a lot of material to cover. Of course, that said, we're not going to cover everything about the G1000. There's a lot to cover, and if we do cover everything, you won't remember like 9 out of 10. So we'll cover the important things, and this will of course make more sense if you've touched the G1000. But even if not, hopefully this will make some sense. And I do have the trainer from Carver, the PC trainer, that I'm going to use for live demo, sort of in between the two slide decks. There are two modules. This is number one. One is basically everything except the autopilot and the flight director, and then two is the autopilot and flight director. So we're going to start with one and then do a little bit of live demo, take a little break, and then move on to module two. Okay, all right. So, and these are CAPS transition slides. So the part of the training towards the 4 and 5, if you're looking for that. I think Garmin has another slide deck, and I think has better visuals. But anyway, there's a lot of material for the G1000 out there. There are books, there are videos, there's YouTube, there's flash trainers. There's a lot of material that's going to save you time and money so that you fly less. All right. So module one is basically what we said. We're going to talk about the PFD, MFD. Oh yeah, and if you have questions, please speak up. So when I'm done with the slide, I cannot monitor the chat because I'm sharing the screen right now. So if you do ask a question at the chat, somebody's going to have to read out for me. Recording started. Beautiful. All right. So this is when if you're a pilot who hasn't flown a G1000 before, or say maybe you're used to round dials, sort of like the older style navigations. Now we start talking about how your situational awareness, how those skills adapt in an airplane that is more automated, gives you more information, it's more integrated. The computer is basically more integrated with the flight instruments. And of course, there's some new terms come into play that like automation management and the levels of automation. So this is some of the stuff we're going to cover. And of course, risk management comes into play as well. Like it is a G1000 aircraft, like we have G1000 182s in Group 2, but they're still airplanes. That doesn't mean that they can do something that you couldn't before. Maybe you're more comfortable in G1000, maybe not. It doesn't mean that the G1000 will get you out of any situation. You also have to be honest about your proficiency in the G1000. What was the last time I flew in G1000? Has it been a while? Yeah. Well, do I really want to fly it a night flight for an actual mission if I haven't flown the G1000 in 6 months? So we have to take all the additional considerations that come with the G1000 in mind. Stuff we're going to be talking about as well. So a lot of what I hope you'll get out of this is not necessarily to remember things. That's useful, of course, but that will come with practice. It's about the logic between the G1000, how you can find something, how you know where things are, how you know how to look for things, and how you know what the system capabilities are. And also, of course, how they help you with your situational awareness. At a very basic, high level, the G1000 is 2 screens. In our 182s, in larger planes, it can be more, but in our 182s, we have 2 screens. We have the primary flight display that we're going to call the PFD. Don't call it PDF, it's an entirely different thing. That's a PFD on the left, and then the MFD, the multifunction display, that's on the right side. Briefly, the PFD is your 6-pack, plus a lot more, but in any case, it's your 6-pack. You see here, as we'll go step by step, you have the basic flight instruments. You also have an HSI, so it also gives you navigation. It gives you a small map, and you can control both radios and both VORs. And it also gives you some course guidance. You also get the flight director, so we'll talk about it for the autopilot. That's the PFD. The MFD is more closely to, like, if you're used to flying a round dial plane with a GPS like a 430 or an Avidyne or something, that's closer to what the MFD is. It gives you the map, it gives you weather, you can do flight planning more easily on the MFD, you can get system settings, get the status of GPS, you can still control the comm and the nav, and it gives you your engine indicators, as you can see here. So when it comes to, I think there's more. Yeah, so the G1000 components, we talk about the screens, but there's a lot behind that we're going to talk about briefly. There's a transponder, just like any other plane, it's just that it's remotely controlled. That's why you won't see it sticking out at the panel, but you're going to set the transporter code through the G1000. And there's two new units. Basically, there's the AirHars, which is attitude, heading, and reference system. The acronym is defined here. And then there's the Air Data Computer, ADC. You can think of AirHars, like if you think of the six-pack, anything that used to have a gyro is now controlled by the AirHars. That means your attitude, your turn coordinator, and well, I guess not your heading indicator. That's the magnetometer, but I think it's that's also part of it. Yeah, and then the air data computer is anything that's static port or pitot tube, so altitude, airspeed at VSI. Okay, and then there's the magnetometer that senses your heading, and of course there's the transport. Yeah, so back to our map, we have the ADC, we have AirHars, we have the magnetometer. And then we have engine monitoring systems. We have a data link for ADSB. We used to have XM. I guess we still have it, but we don't have this subscription anymore. We have the autopilot. We have the servos for the autopilot. But these are the basic systems. Now, what we're showing here is like it's a pamphlet from Garmin. And there is a difference with our CAP planes. This unit in the middle here that's the audio panel. A standard G1000 setup has only one audio panel. Our CAP planes have two audio panels, one for the left seat and one for basically everybody else. And that sort of helps, so you can have like the MO talk to COM3 while the pilot is talking to COM2, and they're entirely independent. It's a really handy thing. It's just that's the difference that you'll see in our planes. We have two audio panels. You can stop me at any time with questions, but yeah. So when you do go and pre-fly the plane, there's a checklist. Of course, we follow the checklist for the pre-flight. You'll notice one of the differences there with pre-flighting a G1000 plane with a round dial is that there's more to do inside the cockpit before going out. Part of that process is you're going to power up the system, and you're going to check the PFD, and you're going to check that some annunciators are there. You're going to check that there's no excess and that kind of thing. So basically, you follow the checklist. When only the PFD on, you'll see the engine indicators on the PFD, but normally when we're flying, we have both screens on, of course, and the engine instruments are the MFD. So, we're not going to go through the checklist. Basically, the point of the checklist and how, not just for the pre-flight, but also how to start up when you're ready to start the engine. After that, just follow the checklist. You'll get familiar. You'll study that before your flight. And but you'll notice that all the different components are sort of starting up at different times. So you're going to check the standby battery. You're going to see initially red excess at the PFD, meaning that the AirHars or the ADC are not giving information. That's because they're still booting, and they're going to complete their booting, and you're going to see all this information displayed. And the attitude indicator has sort of this alignment process to go through. So there's a boot up sequence. Follow the checklist for that. The point is not to memorize any of what's on this slide, but as long as you get the gist of what we're talking about here. And then this leads to an important concept. It's labeled here system startup because you do see that a system startup, but this is the first time I'm going to say it again because it's important. The G1000 has annunciators. Annunciators are messages. The message is to draw your attention into something that's important for the flight. And it has 3 levels. It has advisories, which is just in white, and they're just informational, like storm scope has failed. That's one of them. It has cautions. I'm using the words carefully here because that's how the reference manual uses them. So cautions are in yellow, and they're stuff you'd want to know, but they're not of immediate threat to the flying. Like low vacuum from the vacuum pump is one example. And it has warnings that are in red, and they are something that really should draw your attention right away. So, like for example, low oil pressure or low volts, that refers to the voltage in the main bus. And you'll see them on the bottom right on the PFD. Cautions and warnings will also make a sound, and that's partly what you're looking for in the pre-flight. Right? I'm pausing for questions, not for dramatic effect. But right. So the engine instruments, normally they're on the MFD. They could be on the PFD at startup, or if the MFD fails, there's, I think towards the end of the slide that we talk about that. But the engine systems basically have 3 sub-pages. This is the default one. Shows you your manifold pressure gauge, your RPM, your fuel flow, really useful instruments, oil pressure, oil temperature, your the CHT of the hottest cylinder. It even tells you which cylinder that is. So right now it's showing you the CHT, that cylinder head temperature of cylinder 1, and you can see little 1 at the indicator here. EGT, also the hottest one. Fuel quantity, left and right, and electrical system. So the electrical system, you get volts and amps from the standby battery and the main battery, and I mean the main bus and the essential bus. Now, this leads to one of the big differences. We have 2 batteries on board. We have the main and the essential one that we're going to talk about more in detail later. But have that in mind. There's 2 batteries on board. All right, PFD. These are the basic components, and this slide here tries to map the 6-pack that you're used to into where it appears on the PFD. So the big thing in the center is your attitude indicator. It's nice and big, easily readable, pretty detailed. Then you have your airspeed, and it's a tape. It's not it doesn't rotate. It's not a circle like the steam gauge's airspeed. It's a tape, moves up or down depending. It has labels. Notice that it gives you VY, V-glide. These are pre-configured in the system. Normally we have them, for example, the best glide speed is for maximum weight. It doesn't mean it's appropriate for your flight at a particular time, but these are user adjustable labels. The rate of turn, actually, I'm sorry, the ball. So basically your turn coordination is this trapezoid. So here we're perfectly coordinated. If we weren't, it would this trapezoid that's underneath this triangle pointing up, that would be on either side. And just like you step on the ball, here you step on the trapezoid if it's to the left. And also these 2 triangles here show you your bank. Now, I think we have some people on the line who have taken this before and know the G1000 and also don't want you to fall asleep. So what is your rate of turn indicator? Question. Okay, maybe I should have asked you earlier. Maybe.
Yeah, isn't it the on the compass, top of the compass? It'll show you your rate of turn.
Yeah. Exactly. Yeah. So you don't see it here. The G1000 has what it calls trend bars, which you don't see it here because it's a static slide. Remind me to show you that in the simulator. Basically, anything that changes, like the altitude or the heading, it gives you a little magenta. Little magenta arrow that shows which way it's changing, and also it shows you where it's going to be in 6 seconds. And that's how you can define a standard rate. I think there's a slide for that gives you the visual cue. So hold on to that term. But it's basically the rate of turn. You can deduce that by the rate of change, the trend bar that is displayed on your compass. All right, and then we have the altimeter. This is the VSI. Currently it's showing 0. That's why there's no number. And also the G1000 has some user selectable fields, and there is logic to the colors. So we're going to get into that later, but for this, it's pretty easy to see. Like this is the altitude select. We also call it the altitude bug. This is entirely pilot selectable, user selectable. It has a function for the flight director, but You can also use it as a reminder. It's light blue. That indicates that it's user selectable. Another thing that's user selectable and therefore light blue is the heading bug. Also has a function with the flight director. Right now, the heading bug is pointing where we're pointing. All right. And there's this other stuff around. So there's a transponder here, the code, the mode it's on. There's a clock. It does know the time. It does tell the time. Outside air temperature, navigation frequencies, and com frequencies. And the way they're formatted, you see there's COM1, COM2, nav1 and nav2. The standbys for both COM and nav are on the towards the outside of the screen. The actives are towards the inside. And you have the waypoint status bar. That's basically your flight plan. It's basically your next waypoint in the flight plan. If you're going direct, tells you which waypoint, distance, desired track, and your current track. That's configurable. So in some places you might see like the bearing being displayed. Okay, so the screens, both the PFD and the MFD, as pieces of hardware, they're identical. They have the same buttons. So you can do almost anything from both screens, and it doesn't really matter. So what Cessna likes to recommend, and I think it's a good idea, but it's just a technique, there's no rule about it, is the left hand is for the yoke, and it stays on the yoke. Your right hand is what pushes all the buttons. And because of the placement, so these here, basically the left side of the PFD and the right side of the PFD and the left side of the MFD are towards the center of the panel. So they're more appropriate for your right hand. So this is what you normally will be using. The audio paddle is also there. That's convenient. Okay, and now we're starting to more into the controls. Again, don't feel bad if you forget a lot of these things. You'll do them in practice. Now that said, if you're familiar with Garmin products in general, like a Garmin radio or a Garmin GPS, that not the touchscreens one so much, but like a Garmin 400, 500, a lot of the logic is the same. It's surprisingly the same. So when it comes to COM, it gives you a volume knob, it gives you the flip-flop switch to make a standby frequency active, and it gives you the knob to tune the frequencies. The standard knob in this hardware has two basically knobs. It's the big knob that's towards the inside and the small knob. Big knob changes numbers, digits, and the small knob changes decimals. Then you have some other stuff. So you have this control that you use to set the barometric setting for the altimeter. You also use it to set the OBS. Like if you have the GPS and OBS mode, or if you're flying a VOR, you use to set this what we call the CRS. Basically, if you remember the old VORs, you set the OBS setting. It's the same thing. Then you have a little range button and joystick because you can get a cursor on the map and move it around to get more information. And then you get these 6 buttons that should be familiar to anybody who's flown a Garmin GPS. You have the direct button, menu that gives you a menu depending on what page you're at, flight plan, the flight plan, procedure, that's for IFR, clear if you want to delete something, and enter if you want to register something. And then you have another knob here at the very bottom that you can use to type or to switch through pages and chapters. I think that's the same thing. Yeah, so these are basically the keys that we just talked about. All right, and then the FMS knob is something you'll be using a lot. As I said, it's something that you type, and you type sort of the Garmin way, where the big knob moves the cursor, the small knob changes the letter, and it just makes you wish, you had a keyboard. But we have to enter like complicated flight plans through that little knob and hope that knob doesn't break. But you'll be using it a lot. And now this knob also has a button. You can push it, and that's how you get a cursor or you erase a cursor. gonna go more into that later. And on the other side, now this slide is, there are different flavors of the G1000. This slide, the planes that we have in Group 2 have an integrated flight director and autopilot. So on the left side of the screens, they have more buttons that have to do with the autopilot. We'll talk about those later. But for this slide, it assumes G1000 without an autopilot and flight director, therefore it has a big gap here. But it still has all the other buttons. So for VORs, you get a volume, a flip-flop, and a tune, a frequency selector knob, same thing. You get a knob to change the heading bug, and you get a knob to change the altitude bug. Those are on the left side of both screens, PFD and MFD. How are we doing so far?
Good.
Okay.
Good. Okay. Okay. So, can anybody tell me why soft keys are called soft keys? What's soft about them?
They have more than one function.
They can change their meaning
Exactly.
to open up different fields.
Exactly. I think you all got it. The function of those keys depends on the current menu, on the current menu level, and it's different between the PFD and the MFD. They do different things. On the PFD, what happens? So the example here is called the PFD, and it's showing you the standard sort of menus. You'll notice that there's the soft keys. The keys themselves, they don't have anything printed on them that tells what they do. This bar here that says insert PFD, all that, that's part of the screen. And that's why these labels change if the function of these buttons change. So that's the label.
So another way of thinking of it is that the function of the keys is determined by the current state of the software.
Yeah.
I think that's where the soft comes in.
Okay. Yeah, good point. All right, so this is the default sort of menu for the PFD. You see you have a transporter key, a CDI, OBS, PFD. If you press one of these, they will lead you to another menu. I wonder if it's worth demonstrating now because you will forget by the time. So just give me a sec. I have the trainer here. If for those who don't know what I'm talking about, this is, you can buy this from Garmin. And of course, there are equivalents for like an iPad and so on. But this is the Windows software, and it gives you, it's a little simulator. It's not official, but it does most things well. And so I've set it to be a PFD. So you see here the soft keys. My transponder right now is a 1200, nice and VFR. If I want to change my transponder code, that's done by soft keys. So I have to press transponder. And now because I did that, I go into a different menu of the soft keys, and now the functions of the soft keys change. So now I select code, I type in my code, and it takes me back to the main menu, and it changed my code. All right, also notice how the altitude bar here changes. I can change it from here. I said, there we go. Yeah, clicking is actually not easy on these things, but it does work eventually. And so on. All right. We'll come back more to that later. Where is it? There we go. Okay, so these are soft keys. And there's a whole bunch. Again, you're not going to remember everything, but it's worth noting that what it means here by inset, that's a little map. It's a mini map that you get in the PFD, and it helps you have a little map, even though for example, the mission observer is busy doing stuff on the MFD. And when you press the inset button, it takes you to another menu that has to do with choices about that inset. So you can basically control the overlays in this case. Storm scope, terrain, topographical, lighting, and so on. And there's also what is called this thing called declutter. So there are different declutter levels to basically reduce the information shown because it's a small map and it can be busy. And there's also soft key that says PFD that affects, for example, the style of your HSI. It can also affect what sort of extra readouts for distance that you might get on the, where am I? That was actually shown. Yeah, so see these things that say nav1, nav2, these are distance readings from waypoints, either VORs or something on your flight plan. And you can enable these or change these by the PFD soft key. That's what I was getting at. And there's more. I don't want to go into everything here. Like each of these has a function. You should play around with it, especially at the simulator. And I do want to talk about the OBS mode because that's sort of important. It's the same thing as the Garmin 400, 500. So the OBS mode hasn't changed in like 30 or 40 years, or even before that. I actually don't remember what the 250 does. But what the OBS mode does, really high level, is it makes the next waypoint, the next GPS waypoint, into a VOR, a virtual VOR. So now you can get a radial from that waypoint, and you can use it to sort of track a certain ground track to or from that radio. And that's what's called OBS mode. It also suspends sequencing of waypoints. All right, and you see this little DME soft key. Let me ask you, the planes that we have in group 2, the G1000, 182, actually all the G1000s, do they have a DME? It's okay. Just what's your best? Do our planes have do our G1000 planes have a DME?
I would say no.
Does anybody else say no?
No. I'll say
Right.
yes.
Okay. So
I'll say maybe.
okay, folks, come on. We have to take a position here. Now we're totally split. Who will be the tiebreaker?
It absolutely does have a DME.
All right. Unfortunately, they do not. So our planes do not have a VHF DME. They do give you distance information, and they can be entirely equivalent to a DME, but they're GPS derived.
Not slant range.
Yeah, they don't have slant range, that's exactly. But we have GPS derived DME, which according to the AIM is a legal substitute for IFR as well. But we don't have a VHF DME. Now, if you have a G1000 outside of CP that has a VHF DME, that's perfectly fine. You can also find a G1000 with an ADF. It's really hard to find, but it's possible.
If it's derived from those other sources, it'll have different colors or something, right? Is that right?
Yeah, I've never actually flown a VHF DME, but you're right, it should. Although actually, I'm not sure about that. So it's gonna show here. You see these little insets? It's gonna show here. I'm not sure about the color. That's a good question.
So George, if I have an IFR approach, say localizer DME, then I would use the GPS distance.
You use whatever the approach asks you to do. So that's going into the IFR part of things, which is not really the focus for tonight. But there's a gotcha. So, for example, if you want to fly the ILS-28 right at Oakland, that approach has you use a DME that is from Oakland VOR, even though you're flying a localizer. Okay. So you have to set it up right that you get an inset here showing you distance to the Oakland VOR, say by putting the VOR in nav2, but you're flying the localizer in nav1.
Got it. And what if the approach doesn't have only has a DME? I wouldn't be able to use. Is that right?
What do you mean only has a DME?
Like in other words, what if it's not like in Oakland where you use the VOR for DME? What if it has a different channel specifically for the DME? I wouldn't be able to use it here, right? So would I use the GPS distance, or since?
Yeah, you can always use the GPS distance, but I'm trying to remember of a DME station that is just by itself and is not attached to anything, either a localizer or a VOR.
Okay.
I can't remember one right now. I guess it's possible though, but I just can't remember that right now. But in that case, so if you have that case happen, I'm not entirely sure, but I think you can still tune the frequency on, for example, nav2. You won't get any course guidance, but if it's in the database, it might work out. I think that's the key. It's GPS derived, so it needs to be in the database. The only reason you're tuning in the frequency for nav1 and nav2 is to tell it what it should be measuring the distance to and from. Now, of course, you can, like, the approach also has waypoints, so and those waypoints will be in the flight plan, so you might not even have to do that. In fact, in like the Oakland approach, you don't have to do that. You can just use the waypoints of the approach, but it's just a nice backup to have the DME distance. Right, that was an IFR detour, but anyway. All right, and going back into colors matter. The colors behind the G1000, there's logic behind them. Anything that's GPS derived is magenta. Anything that's VHF or ground derived, I guess, is green. So this is how the AHSI looks like if the coarse kindness comes from GPS. VOR1 is in the middle. It's green, but it only has one line, and VOR2 is two lines. So that's how you can easily tell if it's tuned to VOR or VOR2. Of course, it also tells you VOR and VOR2, but it's a nice visual indicator because it's kind of important to know what you're flying towards. And the CDI soft key is what cycles through all these three options. Can anybody tell me what those light blue needles are?
I believe that's the ADF.
Isn't that the VOR?
No, I'm sorry. That's
Is it magnetic based?
a turn. It shows the direction of a VHF signal, but not necessarily. It differentiates between that and the course bearings that you set up.
It shows the VOR that you aren't actively tuned to with the CDI. So in the middle one, we're obviously using VOR1. That's why the needle's green, and therefore VOR2 is in the background in blue there. Because you can't use them both at the same time in CDI.
If you notice, RMI1 is also there. It's behind the green. But I think you've got it. Like, I think all answers were pretty much on. These are called the RMI needles. And they are pointing to the nav1 is the single line, and nav2 is the double line. And they just point directly to their stations. So you don't tune the OBS setting or the CRS as it's called. They just point you directly towards them. So it's nice to use them to cross-check, like if you're going to use a cross radial to define a waypoint, they're very useful, or as a backup. And remember, I said that they point towards. So in this case, for example, VOR2, nav2, the heading that you would fly to get to it would be 260. But if you look at the other side of the needle, that tells you the radial that you are from it. So in this case, you're on radial 080.
Hey, George?
Yes.
And you would enable those or bring those up using the bearing 1 and bearing 2 soft keys, right?
Yeah. So you would hit the PFD soft key here, and they would appear. It's bearing 1 and bearing 2, exactly.
Shayan, earlier in the demonstration, you said that if you establish a waypoint, that it can actually show you as a VOR on your screen. So are those VORs that we're looking at, are those real VOR stations, or are those also perhaps waypoints?
So these RMI needles are derived from VORs. So
real VORs or waypoint?
Yeah, real VORs. So when it comes to VOR1 and VOR2, basically nav1 and nav2, those are always VHF. So they're real VORs. Not to be confused with the OBS mode. These RMI needles have to do with nav1 and nav2, and those are VORs. Now, there is a way, okay, here, let me show you. Because I think there is a way to have a bearing needle to share screen to a GPS derived VOR. I've never had to do it, so I don't know. So you should be looking at the PFD. Let's go direct to somewhere. How about we go to whatever pops up first? Keflavik. That sounds like it's in Russia. So enter. Oh, it's in Iceland and Russia and Pakistan. Okay, let's go to Iceland. All right, so now we're going direct to that waypoint. It's 2,888 miles, so be patient. But this is pointing you directly to where we would have to fly. Now, I can change my CDI needle, and now look at its VOR1. This frequency is not in tune, so that's why I'm not getting a needle. It's actually not picking up anything. But I can go to the PFD soft key, and I can go bearing 1. Now, the RMI needle for that nav1 would be to nav1, but it says no data because it's not picking up a VHF signal. But I can also press it again, and now it's giving me an RMI needle to the GPS waypoint.
George, you have a question?
Yep.
From,
What's
I think
up?
it's from Eric Bless. Edward Bless.
No, he just answered my question, so I'm good. Thank you.
Okay. Yeah, so it's configurable. I didn't mean to. Yeah, I should have had maybe a little different wording there. But what I said that these RMI needles are pointing into nav1, nav2. That's usually how we fly them because usually the CDI is on GPS anyway. But absolutely, that's not necessarily the case. You can fly VOR on CDI and have the RMI needles pointing to the GPS. Okay, other soft keys, the transponder that I showed you, and then ident. Also, transponder, see if you press ident, it's going to show you ident to visually show you that it's identing. There is a timer. You can use it for approaches. It's there. You can also change the reference speeds. Please don't unless you have a really good reason, but you can. They're here. And nearest. If you want to find your nearest airports in a hurry, that's a soft key for that. Will tell you the bearing, distance, frequencies, Unicom, and so on, runway length, and available approach types. Really useful tool. Okay, going back to our colors. Colors do matter. Cyan or light blue is pilot adjustable. Green is VHF, ground derived, and active items. Magenta is GPS. And advisory or alert are white. These are sort of the lower priority messages. Yellow are the cautions, and red are the highest priority, and those are warnings. All right, and then from the audio panel, remember if you're on the left seat, you play with the audio panel that's towards the middle of the panel. And then if you're on the right seat, you play for the right seat audio panel. We have 3 comms, COM1, COM2, those are VHF controlled by the DME, by the G1000. And COM3 is our CAP radio. And then you have some other buttons. Some of them don't particularly work because of the configuration. But aux is the Becker. I don't think our planes have an ADF, but they do have nav1 and nav2, so you can listen to the Morse code of the VORs. Don't remember if we have a DME button there, but doesn't do anything. The play button unfortunately doesn't work. So normally the G1000s can replay the last, I don't know, so many seconds that came in from the radio, but that is disabled for us because we have 2 audio panels. And then we have the isolation buttons. Those are fun. Can anybody tell me what those do?
Yeah, they let you control the internet. So there's 3 modes. It's either everyone talking when neither are enabled. You can isolate the pilot from the rest of the passengers and the co-pilot. You can isolate the co-pilot from the pilot and the rest of the passengers, or if you hit both, then you isolate the crew, the pilot and the co-pilot, from the passengers.
That's exactly right. So if you're the pilot and the crew is speaking and it's important and ATC wants to talk to you, so you don't want to hear everything, you can isolate yourself. The key is to remove the isolation when you're done. Otherwise, the crew is talking to you and you're not responding. That has happened to me more times than I can remember right now. And yeah, when you're done, like if you don't want to be isolated anymore, just press that button again. I think that's stuff we talked about. And yes, of course, that's also, so when it comes to COM1, COM2, COM3, there are two options. You can monitor 1, 2, or 3, one or all of those, but you can only speak to one. So if you want to talk to, in this case, COM1, you press the COM1 mic, and there's a little light top of COM1 mic that lights up to remind you that you're talking to COM1. And there are lights on COM1 and COM2, COM3 on the right side. That's the monitoring. That's what you're listening to. In this case, we're listening on COM1 and COM2. We're only talking to COM1 though, and we're not listening to COM3. Right, this is how you change, just like any radio. That knob is, as I said, the big knob changes the numbers, the small knob changes the decimals, the flip-flop switch makes it active. Notice how they relate, though. Actually, I'll just, yeah, I'll give you a little demo a little later. But in this case, we're talking to COM1. The active frequency for COM1 is on the inside of the screen. That's why this frequency is green. It's telling you that frequency is what you're talking to. And if we were to press the flip-flop switch, COM1 would switch, stand by an active frequency. We know that we're editing COM1 because you see this rectangle, the sine rectangle. That's sort of like your cursor. That tells you what frequency you're editing. If I were to twist these knobs, it's this frequency that's going to change. If I were to press the flip-flop, it's COM1 that's going to flip its frequencies. Okay. All right. So as we said, we have two audio panels. There is an automatic squelch also. Sometimes I have to yell to break squelch, so there is a manual squelch button that you can press as well. And if you do that, you see this little knob here. That is used as squelch or volume, depending on if you're on manual squelch or not. And when I say volume, I mean volume of the intercom. The volume for radios is controlled by this little knob up here. So usually what we do is we have the left seat pilot transmitting on a VHF frequency, COM2 transmitting on, the right seat transmitting on COM3, that's CAP radio. It's possible for the right seat to transmit on COM2, so both are talking to a VHF frequency. Of course, be careful with interference, but it's possible. So this is CAPF radio. So COM1 and 2, that's a split mode. That's disabled for us. Becker, play, as I said, is disabled, and so on. This red button here is used to enter what is called reversionary mode, which means the PFD is moved to the MFD. Say that your PFD, the actual screen, the hardware, breaks down. The screen doesn't show anymore. You press that red button, and now your PFD, it moves to the MFD. You still have all your flight instruments or flight data in there. The only downside is that you have to look a little to the right. Okay, so these buttons here have caused some squawks sometimes. Can anybody tell me what the seat select button does?
Does that turn the back seat microphone jack on and off?
Yeah, it's not the jack, it's the push to talk button. But you're right. So basically what happens is normally these systems, they have two push to talk buttons, left seat and right seat at the front. But CAP, we have a push to talk button on the back seat as well. There are cases where we want the scanner to talk on the radio, but the system doesn't support 3 push to talk. So there's the switch, it's what the one we're talking about here, that basically selects, do you want the observer push to talk to be active or the scanner push to talk to be active? You can only have one of the two. And there's a little light here that says which of the two. So right now it's showing, it's highlighting 2. That means the observers push to talk is active. If you press it, it will say 3. That's the back seat. If you're the observer and your push to talk doesn't work, check that switch. It's more often, a lot of the times, that's the cause. And the other button to the right, it selects what COM3 is. In our planes, it should always be, as shown here, FM, because we don't have an alternative choice. If you press that and select the UHF radio, which we don't have, you basically disable COM3. So check those buttons. They're sort of on the lower side. You see the flap control. They're to the left of the flap control. All right, the MFD. What I want you to remember about the MFD, just like the older garments, same idea, is the information is presented in pages, and pages are organized in chapters. So there's a bunch of chapters, and each chapter has a theme. So it can be navigation or it could be maps. And each side, each chapter, there are a bunch of pages. What we're showing you here is the default. That's the navigation map. But the navigation map is a page that belongs to the map chapter. So the chapter on the page is shown here. We are currently at the map chapter, at the navigation map page that belongs to that chapter. And you can see on the bottom right here, the other chapters that you can have that are available to us. I think this is a good place for a little demo because I think a lot of what the slides are showing us, which we'll go through, can be demonstrated. So if you have the Garmin PC Trainer, you can actually change whether you're looking at the PFD or MFD by clicking PFD mode. There's a way to have them both if you have a large screen, but anyway. So right now, map chapter, navigation map page. If I want to change, I use my FMS knob. If I want to change the page, I use the small knob. If I want to change the chapter, I use the big knob. So if I twist the small knob in this case, you see here it pops a menu. This is the traffic map, still the same chapter. This is the storm scope. This is the weather data link, XM. In our planes, the actual choices are different because, well, we have different equipment. And but this is really zoomed out. You can see states. But anyway, and TAWS, which you don't have, that's for terrain. Now, and if I want to change chapters, I twist the big knob, and now I go into the waypoint chapter, which has airport information, VOR information, a lot of good stuff. We go to the auxiliary, status of the system setup, some configuration options, some trip planning information. Then we go to flight planning, which is the active flight plan, which you're going to spend a lot of time on this page, but flight planning and then also flight plan catalog, so you can save a flight plan. And then there's a checklist. Yes, there is a checklist in the G1000 and everything. It's just not convenient to use, so I've never seen anybody use it, but all the stuff is here. And then, oh, I forgot that. And then there's a nearest chapter. And there's a page for nearest airport, nearest VORs, waypoint, and so on. So if somebody asks you, hey, which is the nearest VOR, just so we have a backup, well, go to the nearest chapter, nearest VOR page. This is a list sorted by distance. That's your nearest VOR. Now, engine indicator systems. So you have, as I said, there are 3 pages. We only showed you one so far, the default one. But if you press the engine soft key, now you have access to the other 2. So if we press lean, now you get EGT and CHT for each of the 6 cylinders. If you're flying the 172, it's 4 cylinders. And if you go to system, you get the takt time. This is a brand new plane. It has only 4 hours, 0.4 hours takt. But this is where your takt time will show up because you need to put in the logs. It's also the only place where you get your vacuum indication. Okay, all right. Moving back to the slides makes stuff we talked about. This is the organization for the MFD. Again, chapters and pages. It is a little different from, plane to plane, but this might be for our planes. Well, there's no flight plan chapter here. Anyway, so just remember the logic behind this, and the things you see here are almost exactly right, but I think we're just missing the flight plan chapter. So the flight plan button that we saw, that's a hardwired button on the right side of the MFT of the PFT. That's basically a shortcut to take you to the flight plan chapter active flight plan page. But you can also go to the page through knob twisting. And in whatever page you have, the menu button will give you different things. So if you're in the navigation map page, it will show you like zoom level or map pointer or how you want to configure what you're looking at or the terrain, how that shows up and so on. Or do you want a fuel range ring and so on. All good stuff. Now, don't, for consistency's sake, don't change stuff unless you really, really have to, but that's fine if you do as well. So for example, here you press menu, we go to the map setup and you can set the topological data, obstacle data, like how far away obstacles show up, basically, and so on. Same for land. All right. And now maps have this range button. You twist it, and that controls the zoom level of the map. So you can zoom in and out. Okay, for the MOs of the group, how do we get lat long distance? I'm sorry, lat long. Right, okay, how do I get the lat long of our current position?
Push the range button.
All right, so I'm gonna go to the map chapter navigation map page, and because it's the default, I can do that by pressing and holding clear. So this is it. Now you'll notice that this looks a little different than what I showed you before. That's because of the overlays. I can press map. I can now have the terrain. This means that I'm within 100 feet of terrain because we're at 0. Topological is sort of, it shows you the elevation of the ground and other stuff. As John said, if I press the range button, remember how I said that this is basically a joystick, you get a cursor? Now I get a cursor, and this cursor by default starts where the plane is at the time you pressed it, and it tells you your lat long. Now, of course, I can move it. It's a joystick, and it will tell me the lat long. And it also tells me more things. So it tells me like the elevation of the terrain of where that cursor is pointing. If I find airspace, it will also, yeah. So see, this is Kansas City class Bravo. See, it's highlighting the borders. That's how I know what I'm looking at. Ceiling 8,000, floor 4,000. Really useful information. Okay.
Some later versions of it's not. I guess it's not the 1000. Probably it's something later part as a touchscreen, right?
Yeah. So like the G2000, G3000 has a touchscreen, or the Garmin GTN 650 or 750. So if you fly the 206 that we have in Palo Alto, that has a GTN 650 and that has a touchscreen. So it's a little different, but not that different.
Actually, it's a not quite the same GTN number because the 206 does not have the integrated Navcom.
Right,
stuff.
it's the 625 to be exact, but it's the same thing except for Navcom. But oh yeah, just like 6183 Echo doesn't have a Garmin 430, it has a Garmin 400 because it doesn't have a Navcom. Okay, MOs. How do we create a user waypoint?
You can press enter in the joystick mode.
So so you can create a user waypoint if the waypoint that you want is where the cursor is. You can press enter, gives you a choice. Takes you, well, if it has more than one functions, it will ask you what you want to do. But here it's basically in the middle of nowhere. So it gave me the only choice that I have, which is create a user waypoint. But what if I want to create a waypoint given lat and long?
You have to use the FMS knob and go over to, I don't know, I have to see it.
Waypoint.
To
Waypoint chapter, user
Yep.
waypoint page. You
There
see
it
the
is.
soft key, it says new, press new, you type the name. Okay, if this is my name, what do I have to press to register this name?
Enter.
Enter. Do not press the knob again. If you press the knob again, your cursor will go away, your changes will go away. That is a mistake you're going to make more times than you would want in the G1000. It's a very common mistake. But remember that enter is what enters information into the system. The knob just types them, but enter just registers them. So in this case, I press enter. Now it remembers the name, and now I have the other choices. Now there are different kinds of waypoints. The one we usually use is lat and long, so we define it as a lat and long. And then I go in and type. I'm not gonna do anything fancy here, but here, enter, enter. And now I have a waypoint. Apparently it's over water. Too bad. Oh, oops, sorry. So that happens a lot in a typical mission because the G1000 does not know grid. So if we have to go search a grid, we might have to program in the four corners. All right. Obstacles. If you're within 100 feet, they show up red. We do not subscribe to the obstacle database. So if there's a new cell phone radio tower that's in front of you, it might not show up. None of what we're talking about here substitutes pre-flight planning and looking at the window, but it's really helpful. All right, and then there's a traffic map page where it always shows you traffic, also great for situational awareness. And just like other navigators, it's a sort of level. So if a traffic shows up in yellow, that means it's assumed to be a threat. And if it shows up a little diamond, it's less of a threat. If it's a diamond that's filled, like a white diamond, it's sort of becoming a threat, but not really a threat yet. So basically it has 3 levels. And it shows you the relative altitude that you have to the traffic. So 0 means that you're in the same altitude. And you also have this line that basically shows where the traffic is going. You can overlay that information on the map as well. It's just that the traffic map page shows you only that for decluttering. Storm scope, not for storm penetration, situational awareness. We don't get many thunderstorms around here, so it's less important, but it does show electrical discharges, so that's useful. And then we have, well, we would normally have XM weather, but that lapsed and it's not yet configured for ADSB weather. So right now it doesn't have any onboard weather, which makes me sad, but normally you would get some sort of weather showing here, and that can also include TFRs, NOTAMs, METARs, really cool stuff. One day maybe we'll have them again.
What does it depend on at this point?
So the G1000 that we have worked great with XM, but since ADSB came, XM is an unnecessary expense, so that subscription has lapsed. But the systems have not since been configured to get their weather from ADSB, which is possible. Maybe it's a firmware upgrade, I don't know, or maybe it's just a configuration, but it needs to be done by a Garmin dealer. I don't think it's available to the user, at least as far as I know. All right, then we have, let's see. Yeah, you can also get meters and TAFs for a particular airport. Again, right now you can't, but if you go to the airport information page, you can get all that. You can actually get a lot more here. Let me show you real quick, because this is also something cool. So if I go waypoint, I go to airport information, it's going to show me some airport. I can change it, but no need. And then it shows you the runways and the frequencies. But if I press weather, it will show me weather if it is reporting weather. This is IFR stuff. And if I press info, this is sort of the page we started with. But there's more info to be had. There's in the second info page with phone numbers and so on. We did not subscribe to this database. We only subscribe to the navigation database. So this information here, like the phone numbers or left traffic pattern altitude, those may be out of date. Okay, right. So, oops, I went back without sharing again. All right. So, terrain proximity, red means you're within 100 feet or less. Yellow means within 1,000 feet. Remember, pilot 70-1 for sustained flight, we have to be 1,000 feet AGL. So for sustained flight or normal flight, you do not want to be flying over yellow. That's what that means. Remember, we don't update the terrain database, at least not often. It says annually here, but I think it's less than that. And so it's really for a situational aid. This is the GPS status page. You can check the GPS status. I don't want to spend too much time on these little details that you're going to play around with when the time comes. Then you have intersections. You can get the nearest intersection. I'm not sure why you would want to do that, but there's a nearest intersection, just like there's nearest everything, ADF, VOR, airport, and so on. So you can get a list of those. And then we talked about the annunciators. The cautions and warnings give you an audio chime, that's called here. Cautions give you only one. Warnings give you repeated warning tone until you acknowledge the warning. And this is some example. Oil pressure is like when the oil pressure is less than 20, low volts, the main bus is less than 24. Pitch stream, if that is enough, then vacuum, low fuel, left or right, standby battery. So these are just some examples. Oil pressure, low voltage, standby battery come on during the pre-flight. So this is stuff we look for. The other stuff, not normally. Although low vacuum you might get, especially if it's a hot day and you're ground all the way idle, you might get a low vacuum. And for each of those that you get, or at least for most of those, there is a checklist, the emergency checklist that you should reference and use. So the takeaway message here is if you get an annunciator, find out what's causing it and then follow the appropriate checklist. In this case, the checklist might tell you to cycle the alternator. So you'll keep the battery on, you cycle the alternator, see if the same thing happens or if that changes. If not, this might indicate a alternator failure, so you start shedding loads. But really, follow the checklist. Same standby battery. That annunciator means that the standby battery is consistently discharging for more than half an hour, for more than 10 seconds, which is abnormal. It should not happen during normal flight. Low vacuum, it can indicate low vacuum pump failure, but as I said, like if you idle low, that really only affects the standby attitude indicator. Okay, so in this case, the Earhart's attitude and heading reference system failed. You know that by the big X that's staring right in your face. Can anybody tell me if the Earhart's, that's the only thing that's failed, is the airspeed and altitude still accurate?
Yes.
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 Yes, they're independent units. Now that said, when we practice, we usually practice for both of them failing at the same time, and that's partly because it's the worst case sort of. But why else do we usually practice for Earhart's and ADC both failing at the same time? It's because for whatever reason, Earhart's and ADC are on the same circuit breaker. So if one of them causes it to pop, the other one's going to go down as well. All right, the magnetometer failure. So in this case, and in this case, notice that you don't have a heading because the heading depends on both the magnetometer and the Earhart's. So in these cases, is the GPS CDI needle, is that accurate? Does that work?
I would say no.
think it's yes.
It does work, but it doesn't rotate anymore because it doesn't know the heading.
Yeah.
So it's not an HSI anymore. It's an CDI, old style. All right, this is the ADC failing, but in this case, the Earhart still works. So you still get attitude and heading and all that. If you lose your COM and navs, this is how they look like. So as you can see, there's a common theme here. If something has failed and the G1000 has detected the failure, it will show you with big X's. So it's pretty clear. Now, if you notice some, there's some training videos about it. There is sometimes, so if your Earhart is going to fail, the G1000 doesn't necessarily know that right away. So there is a period of time where you might get weird indications. So that's why we tell cross-check. We use standby instruments every now and then, especially if you suspect something is wrong. Like if you get conflicting indications, like your airspeed is increasing where the nose is illustrated to be high. So anyway, in this case, it's the integrated avionics unit that failed. Of course, you can have engine indicators failing as well. If you want to demonstrate these things, do not pull circuit breakers. This is a sketch of the electrical system. So there are two batteries. The main battery powers everything. The essential battery powers only the essential bus. So this bus is really meant for stuff that are helpful to get out of a bad situation if you lose your electrical system. Notice that you have 6 buses. 2 mains, 2 avionics, essential, and crossfit. And you don't have to memorize everything, basically what component is on which bus, because the circuit breakers are labeled, thankfully, on the plane. So if you have any sort of situation, you can find out. But as a little quiz, let me ask you, do you have flaps on the essential bus?
Nope.
No.
No flaps. That's why I like to practice no flap landings. Do you have any sort of lights?
No.
The only light you have is the standby instrument lights. But otherwise no lights. So you're invisible to other planes, especially at night. No transponder. You don't have the MFD either, it's just stuck with the PFD. You only have COM1 and NAV1, no COM2 and NAV2. The fuel system, there is a fuel flow meter. So when you fuel up or when you start, you tell it how much fuel you have and it starts counting down by the fuel flow. That's entirely independent from the fuel gauges. So it's nice to have sort of this redundancy of 2 things showing you the fuel. Still, we need to do our visual checks. We usually fuel most planes 182 G1000s at 50 gallons. There is like filler necks, and we used to use them. The bottom of the filler neck is 64 gallons. Anyway, now we're getting more to the details. Yeah, but yeah, we fuel them up to 50. Also, notice something interesting here. If there is an abnormal indication, it could be a hot CHT. In this case, it's a low essential bus volt. That will be highlighted either in yellow or red, depending on what it is. So it's meant to grab your attention. If you have both, in this case, both the left and the right tank less than 9 gallons, you get a caution and you get a yellow highlight in the indicator. If you keep ignoring that, they will become red, and then now you're suddenly flying a glider. Not a very good one either. So you're gonna go down. Remember, we have to flight plan for 1 hour of reserve fuel. Show you the vacuum gauge. Yeah, weather, terrain, traffic, navigation. These are all advisory. Navigation, of course, we do have the navigation database, so you can fly IFR. What this means is like the airspace. It's advisory only. And then the POH has the kinds of operation equipment list. So if you're wondering, hey, this thing is broken, can I still fly? Well, that list will tell you. Fun fact about our planes, our strobes are required to be operational and sadly they're not LED. So every now and then one goes out, we have to ground the plane, even at broad daylight. Flight into known icings prohibited. Yeah. Okay, so does anybody have any quick questions? We can take like a 3 minutes. We're a little behind, but not too behind. We can take 3 minutes of break and then move on to module 2, which is smaller, but it's getting into the autopilot stuff.
I have a tiny question. On the sim, in the weather thing, I guess it's the map chapter.
Okay.
Do you have the sim there?
Oh, I thought you were just gonna ask. Yeah, sure, no problem. Weather.
It's the, I guess it's the map chapter.
So the weather data link?
Yeah, I was just, does it give you a menu of that? I was just curious.
Well, it's a setup, but really what we usually do is here, you see the soft keys, these tell you what you're looking at. So I can now enable meters.
Yeah, I was curious because you said about changing like between XM and ADSB that I guess there's different weather providers you can choose among.
Yeah, you cannot control it here, and that has been the issue. Normally you would get a weather. So this says XM, but the weather page, I forget in our planes how it's labeled, might say XM. But if that were to change, again, that's not user selectable, but if that were to change, it wouldn't say XM, it would just say weather, or maybe it would say ADSB. I guess we'll see when it happens.
If you had multiple providers, though, that's, I guess, where you would select them, huh?
I don't know if you can have multiple at the same time in the G1000. Maybe. I don't know.
I'm looking at the page from Garmin here. It just says, press the menu button, choose the weather provider. Just curious. Okay.
Okay. Well, that's good to know. Make sure you know there's the G1000 NXI as well, the next generation.
Which is not the one we have?
Our 182s are not. The 172 has the NXI.
Oh, okay.
And there are small differences. I don't know. This may be one of them. It also changes with the exact plane. So, like if you fly G1000 in a Cirrus, it is a little different.
And you see that when it starts, like when it boots, it tells you what system config you have. Or something?
It tells you the make and model, and it's actually in the pre-flight checklist to make sure that it's the correct.
It's the right one. Yeah. Okay.
Yeah. You're not flying a Cirrus G1000. Okay, so if everybody's back, or I guess most of you. Yes.
A side question. Our aircraft all have ADSB, correct? Since we're in the
Yeah. Yeah, all of them do. The roundels included. Okay, so first I need to start the presentation. So as I said, module 2 is about the autopilot and the flight director. Now, there are two autopilots that we have in CAP. It's the CAP 140. Notice it's a K, not a C. So it's a CAP 140 autopilot. And I think there's like 2 or 3 planes in California that have this, but none of them are in group 2. So we usually skip this. There are some differences. The most important visual difference is that you'll see that it's a separate module. It's not integrated into the G1000. It's a separate module for an autopilot. And there are differences about how you climb a descent, but they're not that important. I mean, okay, they are important, but they're not that substantial. So if you do get to fly one of those planes, please get some transition training or read out about it. But for those reasons, yeah, we usually don't. And you know, I've only flown that in CAP once, and it was like 6 years ago or something. So it's kind of hard to find one in CAP. Now, this autopilot does exist in other planes before, so maybe you've flown it outside of CAP. I don't know, but anyway, a little older autopilot, but still a good one. The one we have is the GFC700, and it's nicely integrated. And you'll see the buttons that control it, they're part of the PFD and the MFD. They're on the left side. And that system has a flight director and an autopilot. Very important concept. What is the difference between a flight director and an autopilot? Anybody?
The flight director issues the commands to the autopilot, which issues the control movements to the servos.
Yes. Now, the flight director issues the commands to the autopilot. That's correct, but it doesn't have to command the autopilot. It can also show you what you should be doing as the pilot. Basically, flight director is the brains. The autopilot is just the muscles. It is told what to do. It's not smart otherwise. So this is what we're going to talk about, the anatomy of the autopilot system and so on. And these are the buttons in more detail. Again, on the left side of the PFD and the MFD. The most important button when it comes to autopilot is the AP button. It engages the autopilot, also disengages it. FD, flight director, engages the flight director. So you can have the flight director on with the autopilot off, but not vice versa. And the other buttons, all the other buttons below, change the mode of the flight director. So the heading button will take you in and out of the heading mode. Altitude, in and out of the altitude hold mode. Nav, now we're going, so that has to do with following a GPS flight plan if you're in GPS, if the CDI needle is on GPS, or keeping the needle straight if you're flying a VOR. I will demo that. It's, I think, more easily understandable in the simulator. Vertical nav is basically the vertical path, so you can draw from A to B. You can tell it what altitudes you want to be at each of those waypoints, and it will calculate the rate of descent. It's pretty handy. Approach and BC, they're for IFR. That's for another day. And then vertical speed and flight level change are how we change altitudes. Those two, actually, for all of them, what you need to know for all of these modes is that each of them has a goal. It tries to keep something constant. So the heading mode keeps the heading constant. Altitude mode keeps the altitude constant. Nav mode keeps the needle centered. They all have something that they keep constant. Vertical speed keeps a constant vertical speed. Flight level change, the name is a little confusing, but flight level change keeps airspeed constant. And then nose up or down change what airspeed or vertical speed we're climbing or descending at. Okay, I think everybody should know this if you've done all these trainings before. If we want to climb, do we climb vertical speed, flight level change, and why?
Flight level change to climb.
Flight change.
Why?
So you don't stall.
How would you stall?
As vertical speed, you tell it, you give it a speed that it has to try to, a rate that it has to try to keep, and that rate could exceed your stall speed. Whereas flight level change, you were telling it to get to a certain altitude, and it's not dependent on the speed.
So in both cases, they're going to go to a certain altitude. So the altitude bag works the same. We'll talk about that. But other than that, you're exactly right. So what's going to happen is, say that I want to climb by 2,000 feet. If I say I want to climb at 500 feet per minute, I press vertical speed and then press nose up until it says 500 feet per minute. Great. The plane is going to try its best to maintain 500 feet per minute climb. If I don't give it throttle, it will keep trying its best until the plane may or may not, depending on the parameters, stall. If I do the same thing on flight level change, if I ask it to climb at, say, 85, 90 knots, and I don't give it power, it might not climb, but it will maintain the airspeed that I told it, and therefore it will not stall. Okay. Now you'll see on the top of the PFD the different modes of the flight director. So as you see here, is the autopilot engaged?
Yes.
Yes. Your one and only way of knowing is that green AP. And is really what you should be looking at. There should be one person between the pilot and the autopilot flying the plane. Exactly one, not zero, not two. and the pilot knows if the autopilot is on by looking at that AP. Now, next to AP, there's different modes. The modes that have to do with bank are to the left of AP. The modes that have to do with pitch are to the right of AP. The active mode is in green. What active is basically the mode that's controlling what the flight director is doing. The white modes are modes that are armed, but they're not active, meaning they're not actually telling the flight director what to do, but they're armed. They're waiting for something, for some condition to come through, and then they'll become active, and then they'll start telling the flight director what to do. Notice a basic element of the flight director, the magenta command bars. So based on the modes, this is what the flight director has determined the plane should be doing. So if the plane should bank to the left, these magenta bars will show a bank to the left, or pitch up or down, likewise. So in this case, we're flying a GPS, meaning we're flying the CDI needle GPS, flying a flight plan essentially. The localizer mode is standing by, is armed. Now we have altitude hold. We're maintaining 3,300 feet. See that here, the glide slope. That's what GS. This is IFR stuff, but anyway, there's another mode, glide slope in this case, that's armed. Yeah, so these magenta bars are the wedge bars, and if the autopilot is on, and that's why we said the autopilot is just the muscle. All the autopilot does is it puts the yellow, which is what the plane is actually doing, to touch the magenta, which is what the plane should be doing. The should be doing is generated by the flight director. The is doing, actually making that happen, is the autopilot. But if you're flying a flight director without the autopilot on, it's your job to put the yellow next to the magenta. Autopilot is the muscle. Okay. Yeah, so if you press only the FT key, you get only the flight director. You get flying wedge cues, depending on what you select. I'm going to demonstrate some of these things, so we don't need to go through that text. But all right, so let's say that the flight director is off, and you press the AP button. That engages the autopilot, but you cannot have the autopilot without the flight director on. So that will also give you a flight director. What is the mode that the flight director is on right when you press the autopilot? What's the first modes, two modes?
Roll.
And?
Roll.
And pitch
roll
hold.
and?
Pitch hold.
Pitch, exactly. So roll defaults by saying, I want to keep a zero bank. And pitch defaults saying, I want to keep a zero pitch. All right. And then you can...
Keeps whatever pitch it had when you push the button, doesn't it?
You may be right. I thought...
I think that's right.
Okay, yeah. What I was going to lead to that, you can change both the bank and the pitch later as well with the control wheel steering button, but we're coming to that. Okay. So part of the pre-flight checklist is also that you have to override the autopilot, you have to disengage, you have to see that you can disengage the autopilot. This is the left-hand yoke. You see there's the push-to-talk button, control wheel steering button, easily confusable, but they do very different things. The red button here is the autopilot disconnect. If you disengage the autopilot, you will get a flashing red, flashing yellow with a chime, actually 3 or 4 chimes, and that will tell you that it's basically meant to tell you, make sure that you know that the autopilot is disengaged. Has anybody seen a flashing red on the autopilot?
No, thankfully.
What does it mean?
Flashing red means that there's an error that's been detected in the autopilot and it's been disabled.
It means that the autopilot disconnected itself. For some reason, yes, there's some error. Who knows what the reason is? But the point is the autopilot disconnected itself. And in that case, you'll get a red flash and you'll get a chime, but it will chime for longer. It really wants to make sure that you know that. And actually, the chime is important. The POH section 2 limitations, there's a page on the GFC700 limitations. So basically when you can use the autopilot. One of those limitations is that to use the autopilot, the audio needs to be operational and the speaker. So basically you need to be able to hear the chime. Okay, so this is going to a little bit more of technique. So you can use the heading knob to set the heading back to the runway heading, and then the altitude bug to set the first level of altitude, and you can even pre-select the flight director. But what is the minimum altitude that you can engage the autopilot at after takeoff?
Is it 800?
800. Yep. Except for instrument approaches, but yes, otherwise it's 800. Because they want you to have some altitude in case something, you know, the autopilot does something crazy. You should have some altitude to recover. So this is roll and pitch. The flight director is on, the autopilot is not. So this now we're flying with only the flight director.
Question?
Yes.
Does that 800 apply to missed approaches?
Yeah, so missed approaches are part of an instrument procedure. So, but there's another limitation that when you're doing a missed approach, you cannot re-engage the autopilot until you establish a climb. So how it works, and this does change in other planes, other flavors in G1000, but for our planes, how it works is if you decide to go miss, you press the go around button. That disengages the autopilot. You establish a climb manually. You can set the flight director, and then you can re-engage the autopilot. But you don't have to wait for 800 feet if you're doing the miss. Okay, so since I mentioned that, how many ways are there to disengage the autopilot?
Well, there's a trim switch, I think. And there's a disconnect switch on the yoke. And there's the auto AP button.
Mm-hmm.
I don't know if I've got them all.
And the circuit breaker.
Control wheel steering.
Control wheel steering does not disengage it. It only disconnects it temporarily. We'll talk about that.
The go around button.
The go around button disengages. Basically, everything else we talked about will disengage it. The circuit breaker will turn it off. That circuit breaker is the only one that has a white ring around it, so it's nicely labeled. And also, it's part because the autopilot also controls the trim. If you try to use the electrical trim, it will disengage. But also, that breaker is important because if you have a runaway trim situation, the checklist calls out to pull that breaker. Not as the first step, but as you go down the checklist, it calls, and that's actually a new item in the new Form 5 is to demonstrate that.
You pull the autopilot breaker? Is that what you said?
Yeah, because the autopilot breaker also is the electrical trim. So if you pull the autopilot breaker, you also disable the electrical trim, which is a good thing if you have a runaway trim.
Yeah, I've been wondering about that ever since the 737 MAX fiasco.
Yeah, we can disengage it here. Okay, all right, and then I actually part of your Form 5 is also to demonstrate that it's a mandatory item. What happens in a runaway trim situation? And the first thing the checklist says is firm grasp of the yoke. So basically, don't let the plane climb or descend, whatever it wants to do. You'll notice that you actually have to push hard. You have to exert force. And then do the rest of the items, which is press the disconnect button, change the trim, and then the breaker, if I remember right. Okay, so this basically says what we talked about before. If you want to climb or descend, adjust power. We talked about why on the climb, but even on the descent is useful because if you want to descend and you maintain cruise power, that's going to be a pretty exciting descent. And you might reach the yellow arc actually you typically do. But both vertical speed and flight level change have a goal. The goal is displayed here right in front of you. You can change the speed or the vertical speed by the nose up and down buttons. So let's see, stuff we talked about before. Yeah, stuff we talked about before. I'll demonstrate how flight level change and vertical speed work, so you don't need to read or memorize all that. And I also will demonstrate what happens if you're in nav mode and you press the CDI button. Okay, control wheel steering button. What does it do? Anybody?
Temporarily disengages the autopilot as long as it's pushed.
Yeah, so it says disengage here. It's more of a disconnect, because disengage for the autopilots. I'm sorry. What we talked about before, disengage, is the autopilot sort of basically stops working. It's sort of you turn it off. Here, you basically disconnect the servos from the control surfaces. So the autopilot is still working, still trying to do what it wants to do, but it gets disconnected. And in fact, if you're on the ground, you press the control wheel steering button, you can actually hear the mechanical parts moving to make the disconnect happen. It's like a tank. If you press, yeah.
No, I was going to say that it also makes it easier to overpower the autopilot if you press the button as opposed to trying to do it manually.
Of course, yes. Because the autopilot is no longer on exerting any forces on the control surfaces. It's trying, but it's disconnected from the control forces.
And does that stop the autopilot from changing the trim?
That's a good question. I believe not. It's a good question, though.
It may depend on the airplane. I know in some airplanes it does disable the trim control.
Yeah, that's a good question. I haven't really thought of it, because control wheel steering is really meant to be a temporary thing. It's like you want to avoid traffic, you want to avoid something else, or you're in roll mode and you don't want to be in roll mode with 0 bank. You want to be in roll mode with 20 bank. Something else that control wheel steering button does is it changes the goal of roll and pitch and altitude hold. So say that you're in roll mode at 0 bank, press control wheel steering, hold it, establish the 20-degree bank yourself, and let go of the control wheel steering button. It will maintain that bank. Okay, this is here. So when you disengage the autopilot, you can disengage the flight director, but you don't have to. I usually suggest, if you're not gonna use the flight director, disengage it as well. But if you're gonna use it, leave it on. Basically, you don't want to have something right in your face that you're not using. It might become confusing. Okay, the go around. When you do, this is more relevant for IFR, but you can use it for VFR as well. When you press the go around button, that takes both pitch and bank to the go around mode. And the go around mode is 7.5 degrees pitch up, straight ahead. Okay, so I'll do some demos. Oh wait, no, yeah, that's it. I'll do some demos of what we just talked about, because it's a lot of talking. But does anybody have any questions until I find out?
Yeah.
Okay, go ahead.
Yeah, does R172 have a go around button? Because I've never seen it.
I'm pretty sure it does, right?
Yes.
Yes, it does.
All right.
Okay, so this is the PFD. I'm on CDI. Let's go back to GPS for a little while. All right, so I'm going to establish some throttle here in the trainer. And I thought that was control forward, but now I'm doubting it. Okay, why is this plane not starting? We're not paused, are we? No, we're not paused.
Can't you do it by menu?
Yeah, just use keyboard for joystick. Here it is.
Parking brake, George.
Yeah, right.
I was going to say wheel chocks.
Okay, yes, I will do it by menu because something's going on here. Do you want to go to 100 knots today? Let's see. Okay, this 90, sure, why not? So we're gonna go at 90 knots, and right now we're trimming the trees because we're on the ground. So, but that's fine for now. Let's say the first thing I want to do is climb. I feel pretty motivated to climb right now. So when I press the autopilot button, notice that as we said, we're gonna go to roll and pitch. The autopilot is on. I know that because it's here. The altitude select mode is armed, and it will become active when our altitude becomes equal to the altitude bug. I'll demonstrate that. Now, if you buy the Garmin trainer, there are a bunch of versions. Each version has different bugs. My version has the bug that the flight level change button doesn't work. That's version 12. If you want different bugs, buy 13. So I'm going to have to climb with vertical speed, which is, I know what we said we shouldn't do, but this little toy will not climb otherwise. So I'm going to say vertical speed, and I'm going to say nose up 500 feet. And notice that the flight director is pointing up and the autopilot is following it. So now we're climbing. I'm in roll mode. If I press heading, I'll go in heading mode, and that's going to make the plane go turn and match the heading back. So that's how that looks like. Now I'm in heading mode, and now I'm turning to find the heading back. By the way, this is a PFD with synthetic vision, which we do not have. So all you're going to see in CAP is going to be blue and brown. There's an obstacle ahead. I hope we clear it. All right, so now we're climbing. We're following the heading bug. Let me go to my waypoint again. So notice that I'm direct to this KF. This is the distance. This is the bearing. But I've deviated. So let me reset that. I'm going to go direct again. Turn right to 032. But it's not actually going to do it because I'm in heading mode. If I want the flight director to follow that, I'm going to press nav mode. And now I'm on GPS. And GPS just keeps the needle centered. And in this case, the needle is pointing straight towards that waypoint because that's what I've dialed in. Okay, how high is the terrain over here? We're still on it. Anyways, okay, so.
Here in Kansas, it's flat.
Yeah, right. But anyway, what's going to happen if I press the CDI button?
It's going to show you a green arrow pointing to what nav1 is, but since nav1 doesn't seem to be identified, it's just going to have a dead arrow basically pointing up.
Yeah, so that's going to happen to my HSI. That's correct. What about my flight director mode?
I think it goes to roll, right?
I don't know if you heard that. There was that one. You see the altitude bug flashing? That's the 1,000 foot warning. And now we're off the ground. But you're right. Yes, it does go to roll, but it's okay. We also have terrain warning in this plane. Enjoy this because we don't get this in CAP. Okay, so if I press the CDI button, it will go into roll mode. That's correct, but it will be annoyed because it's not really good practice. So it will flash yellow. So notice what happens here. Press CDI, GPS flashes yellow. It's similar to the autopilot. It's basically saying GPS disconnected. Okay, how do I disable sound? There we go. Okay, so yeah, it's going back to roll mode. And then if what I can do is I can find the VOR and show you how that works. Well, actually, first we're gonna level off because we're getting close, and I can speed it up a little. The simulator doesn't understand physics, by the way, so even if you climb harder, it will maintain airspeed. So what you're going to notice is that the altitude select mode, now it's in white, it's armed, it's waiting. When that's the 200 feet warning, it's flashing. When we get close enough, this is going to become a flashing green, means now altitude select will be active because the altitude is going to match the altitude bag. See, now it's active. So now we're in hold mode for altitude. Now it's maintaining 2000 feet. If I didn't have an altitude bag set, or if I had an altitude bag set below, it would never stop climbing. Okay, let me also demonstrate. Oh, I said Romo. Yeah. Okay, so we'll go to MFT. We'll go to our nearest VOR because I want to find a frequency. We're somewhere in Kansas. I don't know the VORs there. And let's see, nearest VOR. Kansas City MO. What's it? 113.25. I have different options to tune it. I can get a cursor, scroll down. Wait. Or enter. I guess I do have to scroll down. Yeah, select frequency window. There's a better way to do this, but anyway. Enter. So now I put 113.25. That's going to be my VOR. Go back to PFT. Now I'm going to tune in that frequency to be active in nav1. I do that with flip-flop switch. Now it's active. It will listen to the Morse code and identify for you. Really handy. And this is the needle. Now I can twist the needle. Oops, that's the barometric setting. Yeah, see, it's easy to make a mistake. Okay, so I can twist the needle just like a CDI, and I can keep twisting it until the needle centers. So it centers here with a setting of 0.36. Is that to or from?
Well, both of the arrows are pointing in the same direction, so I think it's 2.
That's right, it's 2. So if I press nav here, goes to VOR mode, it's going to point towards the VOR. All it's going to try to do here is it's going to try to maintain the needle center. If it flies over the VOR, it will fly from the VOR, but as long as the needle remains centered, it will be happy. And the thing also, yeah, I was talking about the trend bar with the turn. So I'm gonna make it turn left about 90 degrees. Heading mode. It's gonna go to the heading bag. Notice the trend bar. If that trend bar touches that big white line as it does right now, that's a standard rate turn right now. Okay, so unfortunately, I don't have a control wheel steering button here, so I cannot demonstrate that. I can show you a descent, but that's almost the same thing. So we basically set the altitude bag, let's say 1500 feet. Gonna go vertical speed. Notice when I press it, it's at 0. So nothing's gonna change right away, assuming I don't change the power. But I can say nose down. Now we're going down by 500 feet, and the same thing is gonna happen when the altitude reaches the altitude bag. Altitude select, which is altitude hold, will become active and it will flash green.
George, this might be helpful to set a pattern altitude on descent.
Maybe, yeah. If that works for you, that's great. You can use the altitude bag for the pattern altitude of the airport you're flying to. Absolutely. It's a really helpful reminder. Even if you don't use it for the flight director, it's a reminder. Like you can use it to remember the altitude that you were given. All right. So now I'll speed it up.
Just a little note as George goes through this, something to get in a habit on is practice your scanning. Okay, you don't have to be an IFR pilot to practice your scanning.
So notice now that it's active, flashing green, 1500 feet. Okay, I think that's plenty for tonight. There's a lot more to this system that you're gonna have to slowly pick up on. If you're transitioning from rod dials, the POH is a great read. Some stuff are more complicated, stuff are exactly the same. Get this trainer, really helpful. The reference manual, online training, all great stuff. I'll stay here for any more questions. I think we're done with the material.
Thanks, George. Appreciate it.
Thank
Good
you.
night, everybody. I guess we can
That's good.
stop the recording since there are no questions.
Okay.